We're going to start by getting a view of the comet because that's what everybody is talking about and photographing. And this is Comet NEOWISE. I'm sure you've seen photographs of it on Facebook and on the news. And it is just turned into an evening object. And let me get it worked out here. All right, share my screen. There we go. So there's Comet NEOWISE through the 36th engine. That is the head of the comet, the bright area. You'll notice that it's got kind of a greenish tinge. A lot of people have been, I think we got an echo. Sorry about that, we're still playing with microphones here. All right. Sure. All right. So a lot of people have mentioned that the color has changed to a green tinge in the last week or so, or last few days. And it's very noticeable from here.
Yeah, that's typical of a lot of comets. There is an ice on the comets called cyanogen. And when it sublimates, when it switches from solid ice to a gas, it has that greenish tinge to it. So that's pretty common for comets.
So the comet, look at this yourself, then you want to be looking underneath the Big Dipper. And it's going to get a little bit higher each night, but right now it's pretty well positioned in the sky. So grab a pair of binoculars if you want, go outside and look just straight down below the Big Dipper, and you might be able to catch it.
Yeah, you definitely want to use a pair of binoculars. If you're in a really dark sky location and away from the fog, you might be able to see it naked eye, but it'll look like just this very, very faint smudge in the sky. But in binoculars, it pops out pretty easily. And of course, if you've got a camera and you want to go out and take some pictures of it, it looks great. There's been a lot of photographs. In fact, I brought a few along with me if you want to share them. People have taken photographs both earlier when it was a morning object and now as an evening object. So, you know, by all means, try to do that. Some of you may have smartphones that have night view on your camera. And if you have that, then you want to switch to night view and you should be able to capture it.
Gerald, somebody asked a question. They want to know how we know the orbital period of the comet.
Oh, great question, actually. The comet was discovered on March 27th by the NEOWISE spacecraft. NEOWISE is a spacecraft that is in a polar orbit around the Earth. It's actually what's called a sun-synchronous orbit. So it is always getting its batteries recharged by the sun. And it has an infrared camera on it. And NEOWISE was originally launched to do surveys of stars and galaxies and nebula and so on in the infrared spectrum. In 2011, it was repurposed to search for near-Earth objects using the camera, which can see near-Earth objects better because they are brighter in infrared than they are in visible light. So on March 27th, NEOWISE discovered this comet. It was still pretty far out, but it was headed inbound. And by taking multiple observations of the comet over a period of time by NEOWISE and by a number of ground-based observatories, we were able to calculate the orbit. This is actually a pretty common technique used to calculate the orbits of comets and asteroids. You just take multiple observations over a period of time. We use a technique to precisely plot the position of the object in each image, and then using that we can calculate the orbit. This comet has an orbit that comes from the Oort cloud, which is way out at the farthest extreme of our solar system. It's more than 1,000 times the distance between the sun and the earth. So it's way out there. It's very cold out there. That's why everything is ice on these comets. In fact, I'm going to pull up an image here that I have, kind of give you an idea of what the orbit looks like. Let's see if I can share that. It doesn't look like it'll, oh yeah, well, okay, here we go. Yeah. Yes. Okay. All right, where is it? Oh, here it is. Okay, so you see the orbit. We're just seeing one small part of the orbit. The orbit is highly elliptical. It extends out to the Oort cloud. It comes in, goes around the sun, very close to the sun, and then it heads back out. It actually was closest to the sun, the point we call perihelion, on July 3rd. And it is now on its outbound leg. But as you can see from its position there, on its outbound leg, it actually gets a little closer to the Earth. And so it's actually getting closer to us right now, and it will continue getting closer to us until the night of July 22nd. And then it will start moving farther away from us. But you'll still be able to see it well into August with a pair of binoculars. Like I say, it came from the Oort cloud. Oort cloud is a swarm of icy bodies way out at the fringe of the solar system. And periodically what happens is one of those objects gets knocked out of its orbit, either because it collides with another Oort cloud object or because of a gravitational tug from a passing star. And then it makes its long journey towards the sun. This particular comet has an orbital period of roughly 6,800 to 7,000 years. We're not real precise about that. And one reason for that is that because it's outgassing, because you see all that material being blown off the comet, that actually affects its orbit. And so we can't use the same techniques that we would use for an asteroid, which is not outgassing material. We have to use a little bit of extra math in order to calculate the orbit. So its orbit is a little less than 7,000 years. So if you miss it now, you're going to have to wait nearly 7,000 years to see it again.
Well, the advantage is next time it comes around, we'll have much better cameras. And,
right.
And we'll be able to see more of the tail. So I'll get ready for that.
Okay.
Hold on, let me share the screen again for the, bear with me, folks. There we go.
Let's see, is that still a still shot?
Yeah, it's still shot. I'll take the take a fresh one here.
We probably have drifted.
Probably going to have moved.
Yeah, the comet is moving across the sky. It's moving.
Okay, that's pretty good. Yeah, you'll see that in the last 10 minutes of talking, it moved about, an inch across the screen to the left there. So that gives you kind of a sense on the direction and the rate.
Yeah, its motion is actually about 9 arc seconds per minute of time. So we measure distances across the sky using angles, so degrees, minutes, and seconds. 1 arc second is 1/60th of an arc minute, and an arc minute is 1/60th of a degree. So it's moving about 9 arc seconds every minute of time. So it will drift off to the left there, as you noticed. And Looks like Richard is playing with his exposures here.
Yeah, I got a little bit more of the tail by stretching the image there a bit, and that's the ion tail. I mean the
Particle tail.
particle tail. The ion tail would be, if we were able to see it, it would be coming off kind of like this, following my cursor. But I've not been able to get a view of that yet.
Yeah. The
I
ion
don't think it's
tail,
possible.
in all of the pictures that I've seen, the ion tail has been very faint.
Yeah.
If you can just barely make it out in your image, it's going up and slightly to the left, or to the right rather, in your image, but it's pretty faint. So there are actually two tails to a comet: a particle tail and an ion tail or a gas tail. The ices on the comet, there are a number of different kinds of ices. There's water ice, carbon dioxide ice, cyanogen ice, methane ice, and so forth. And as it gets in close to the sun, that ice begins to change from the solid state to the gaseous state. And that's a process called sublimation. And as the ice sublimates, all of the dirt that's in the ice gets released. So there's sand and pebbles and small rocks within the ice, and that is released as the ice sublimates. And the pebbles, the particles we call them, form a long kind of arcing tail that's often white or greenish white in color. And then the gas is blown away from the comet, but it's blown away in a different direction. The gas is blown away from the comet nucleus by the solar wind. And the solar wind is always taking that gas in the opposite direction as the sun is with respect to the comet. The particle tail is always following the path of the comet in its orbit around the sun. So it's not unusual for those two tails to be separated by quite a bit. In fact, in the right configuration, they can actually be going in the opposite direction. So that white bright tail that you see, especially if you take a photograph with your camera, you'll see that bright tail. That's the particle tail. And if you look carefully, you don't see it very well here, but with a wider field of view, you would see that tail has a it fans out and it arcs a little bit rather than being straight back from the comet.
It's kind of funny, as we do this, I watch it on Facebook to make sure that what we're doing is actually making it all the way to Facebook. And the view on the Facebook screen actually does a pretty decent job of showing the tail. It's actually getting a much higher contrast than on our Zoom screen here. So that's actually not bad. You might have seen some pictures of the ion tail floating around, and people are able to capture that by taking many images and stacking them and then enhancing the blue part of the photograph to bring it out. And I have seen some really beautiful shots of the two tails together. We do have a question. Someone wanted to know how far below the Big Dipper the comet is. And basically, if you take your hand and extend it out like this and put it just below the bottom star of the Big Dipper, it's about where the comet is. And kind of as a rule of thumb. And if you stand there with binoculars, you'll see it. You don't need to know the precise point. What you need are the binoculars. It's kind of tough naked eye unless you've got young eyes. And I know that right now I really can't see it naked eye, but through a pair of binoculars, it wouldn't be any problem.
Yeah, another trick is to take your hand, and if you can imagine where the horizon would be if there weren't any trees or mountains or buildings, and take your hand and spread it like this, and put your thumb, the tip of your thumb, right on the horizon line, and the tip of your little finger will be at about the right height above the horizon for where the comet is. It's about a third of the way between the horizon and the Big Dipper. Oh, really? Yeah.
I am able to see it naked eye from here, and I guess I have young eyes, right?
Yes.
I don't
Yeah.
think so.
Younger than mine, anyway.
Yeah, it really it's kind of like I needed to already know what it looked like and what to expect.
Yeah.
With binoculars, it should be no problem at all.
Yeah. Now, one of the things, the reason we don't see much of the tail in this image is the camera is mounted on the 36-inch telescope, which is a very powerful telescope in terms of light gathering, but it has a small field of view. So we're only seeing the nucleus of the comet, the head of the comet, if you will, and a small portion of the tail. The tail actually extends more than 1 million miles out from the nucleus. So, when you go out there with your digital SLR camera and take an image of it, you get a much better sense of how long that tail is relative to the nucleus of the comet.
Good question. Do comets typically expire?
Over time, yes. Because the comet is outgassing, the ices are sublimating and outgassing, it is slowly losing mass. It doesn't lose very much on just one swing around the sun, but each time it orbits and gets close to the sun, it loses more mass. And over many orbits, hundreds of orbits, it will eventually lose enough mass near the surface to where it slowly stops sublimating. And what happens is down deep inside the comet nucleus, which is about 3 miles, maybe a little less than 3 miles in diameter, down deep inside, there's still plenty of ice, but a lot of that dirt and sand and gravel and so on that's released doesn't leave the comet. It actually stays on the surface of the comet. And pretty soon the comet develops this veneer of dirt and gravel and boulders and rocks that completely cover the ice, so that over time it eventually stops producing a tail, stops the sublimation process or slows it way down. And when that happens, the comet actually has more of an asteroid-like appearance rather than looking like a comet. And there are several asteroids out there that are basically old, dead comets.
You may have already answered this earlier, but what was the speed of travel? Did you have an estimate on that?
I want to say around 30 some odd kilometers per second. Its motion across the sky is 9 arc seconds per minute, but that's just the what we call plane of sky motion in our images. The velocity of the comet as it goes around the sun is constantly varying, and I believe it's somewhere around 35 kilometers per second right now.
Someone wanted to know if they don't have binoculars, can they use their digital SLR? Yeah, what I would do is use the widest field you can get on that camera. So if you're using like the 80 to 200 millimeter, stock lens, put it on 80 millimeter, or if you have a 35 millimeter lens, just use that, or even wider if you own one, and aim it below the Big Dipper and put it on a tripod, take a 5 to 10 second shot, and I'll bet you see it in the result. That's about what you want to do. The ISO should be at like 1600. So ISO 1600, 5 to 10 seconds, wide field of view, aimed below the Big Dipper. And even if you don't see it naked eye, you'll probably end up seeing it in your photograph.
Yeah. And you start out with a wide field, and that gives you a sense of where the comet is. And then you can kind of zoom in and narrow your field of view once you know exactly where it is in the sky.
All right. What do you think? Want to move on to something else?
I heard a rumor that the space station is going to be flying.
Oh, that's true. Okay, what time is it right now? I can't see any of the clocks, even though I got all these computers here.
It's 9:50 right now.
All right, so you know, we could keep talking about comets or keep talking about other, you could show maybe some of those pictures you
Yeah. Why don't I
brought,
show
and we
some
can come
pictures?
back to it. The reason we're doing this is that supposedly at 10 after 10 or 11 after 10, the International Space Station is supposed to cross the comet right about at the head of the comet. So there is a possibility we might actually see that if I take a lot of photographs until it actually happens. So we might give that a shot. It's 50-50. So maybe Gerald, you can put on the other presentation, and
All right,
I'll get ready for that.
let me share my screen here. Here we go. So hopefully you can see that. This first image was taken by Bob Miner. Bob is a member of the East Bay Astronomical Society, and he took this about 2 weeks ago when the comet was a morning object. And you can see how long the tail is. That tail extends all the way up to the top of the frame. And you also can see that it is a curving tail. So that is definitely the particle tail that you're seeing there. And he took this from Tilden Park, up, I believe, at Inspiration Point. Let's see here. There we go. Okay, this second one, let's see if I can remember who that was taken by. Yeah, okay, yeah, that was taken by Gert's wife. Gert Gottschalk is, bear with me just a second here. Gert Gottschalk is another member of the EAS, and Gert is German. His wife often spends time in Berlin. And so this is an image that she took with her smartphone. All right, let's see if I can get another one here. All right, this was taken by Wes Chang. Wes is another EAS member. I'm not sure what the lake is. If Wes is on, maybe he can put a comment on about what the lake is that we're looking at in the foreground. But you can see the comet in the background. And again, this is a morning shot that he took, a really great shot. All right. Oh, this is a good one. Alan Roche, another EAS member, was also up at Tilden Park, Inspiration Point, and he took in quite a few images of the comet, got some great shots of it. After he was done photographing it, someone asked him if he saw the International Space Station, and he said, "What?" And they said, "Well, the space station would have passed close by it." So Alan went back and started just thumbing through all of his images, and sure enough, he found one where he had the space station in the frame. So that long streak that you see, that is the International Space Station orbiting. It's physically not close to the comet. It's just from our line of sight, it looks close to the comet. This image, I believe, was about a 6 or 8 second exposure, and that's why the space station looks like a streak rather than a bright dot in the sky. All right. Here's an image taken by Dan van der Zanden. Dan is one of the volunteers here at Chabot. He's also a member of the Foundation Board of Directors for the Chabot Space and Science Center. And again, you can see how the tail kind of fans out and curves a little bit up and to the right. And so that tells us it's the particle tail. All right. Dave Shaw is a EAS member, also one of our telescope operators here at Chabot. And he has a second home up near Lake Almanor, up in the Sierras. And they get nice dark skies up there. And so he was able to capture this image here a few days ago. As an evening comet, the tail is not pointing straight up anymore. It's now pointing up and to the right, like you see here. And that's just because of the comet as the Earth rotates, our angle of view changes. In fact, the way it works out, the comet is above the horizon just barely in the early morning. And as the Earth rotates, the comet actually rises and it's up high in the sky during the daytime. Now, obviously, since it's daylight, you can't see it. But then as the Earth continues to turn, the comet, just like the sun, moves towards the western horizon. And because it's a little bit behind the sun, it's still up after the sun has set. Excuse me. Got some dust in my throat. All right, one more, I think. Oh, yeah, this one I took from very light polluted skies in Walnut Creek. And there's a map of where to find it.
Oh, nice. That's a good map. I like that. So the Big Dipper is pretty much center of the screen there.
Right here, there's a
And
Big
then
Dipper.
if you follow, yeah, show the that angle on the two stars on the Big Dipper. There you go. Yeah. And then you could just go down.
Just come on down, and about a third of the way up between the horizon and the Big Dipper, that's where you'll find it. Okay.
Do we have a way to estimate the age of a comet?
I'm not sure. I think maybe by looking at its composition, we can get some idea of it. But generally, comets are extremely old. They are left over from the formation of the solar system. So they're typically 4.5 billion years old. Like I say, these originate out at the very fringe of the solar system. And when the solar system formed, all the gas and dust that swirled around the protostar, most of it formed asteroids and planets. But what was left over at the very fringe of that gas cloud became all these icy bodies, and they've been orbiting around the sun. And their orbits take hundreds of thousands of years, depending on how far away they are. The outer fringe of the Oort cloud is actually a little more than a light year away from the sun. So that gives you an idea how far away they are. And these objects have been sitting out there, slowly orbiting the sun. And every once in a while, something causes one of them to be dislodged from the Oort cloud, and they come in towards the sun, and we see them as a comet.
Okay, I'm more or less set up for this if we're going to be able to actually see it. It's like hitting we're basically looking at a bit of the sky about the size of a pea, and we're hoping that the International Space Station passes through it.
Yeah.
I don't know. I mean,
Now
this
you
works.
said
I'm going to go out and buy lottery tickets tonight.
you said it was supposed to pass very close to the head of the
Very close to the head, so we got a good chance of seeing
I wonder if we need to reposition the telescope a little bit.
Yeah. The head further up in the.
Yeah. Are you in live view now?
No, I'm not. I can do that.
So we'll get it centered up in the field of view, and
I think that'll be good. Might as well have a nice view of the tail while we're doing it.
So that's live view?
Okay, we can start a betting pool here.
Is that live view, Richard?
No, it's not live view. I'm just taking frequent short exposures.
Oh, because the space station is going to go through the frame real fast. Yeah. So
it's going to be. I'm going to start taking photos one after another. They're 2 seconds long, and we'll see if we can catch it. And that's going to be at 10, 11, and 58 seconds, apparently. So we've still got 10 minutes.
Okay. All right, check the humidity. Oh, yeah, we're good. So for those of you who are living down in, Oakland or Berkeley, you probably are looking up and seeing fog and wondering how we're doing this. We're kind of fortunate. The fog is below us right now. So we are fog free up here at Chabot. And so we've got great views of the comet. And after we're done looking at the comet, we'll have a chance to look at a few other cool objects. And then a little later on, we'll actually be able to see Jupiter and Saturn. So lots of things to look at tonight. But right now, our focus is on the comet. Now you see a few other dots in the frame there. Those are actually background stars. And as the comet moves, it will change its position relative to those stars. There was a question a while ago about how we are able to track these and calculate the orbits. Actually, one of the things we do is we take images like this and we identify stars in the image, and we then develop an equation that relates pixel position of the image to the star's coordinates in our astronomical coordinate system. And once we do that, we then look at the pixel position of the comet, and we can convert that to what we call right ascension and declination, which is our coordinate system that astronomers use for objects in the sky. And once we have that information, we can then go ahead and calculate the orbit. But we can't do it based on one observation. Despite what I've seen on a few dramatic TV shows about comets and asteroids, it takes more than one observation in order to calculate the orbit. Typically, it takes 3 or more observations over a period of time. And the longer the observation arc, in other words, the longer the period of time between each image, the more accurate is your orbit calculation. And the calculation process itself is actually pretty complicated. The original technique was developed by Carl Gauss back in 1801. And he did this after the first asteroid was discovered. Ceres was discovered by a guy named Piazzi, an Italian astronomer. And he was only able to observe it for a few weeks before it got so far over into the twilight sky that it was no longer observable. So all the astronomers of the day wanted to figure out when would they be able to see it again, and nobody knew how to calculate that. So Carl Gauss, who was a brilliant mathematician, he figured out a way of doing it, but it was a really complicated process of multiple calculations in order to develop a prediction for where the comet or the asteroid would be a year later. And it turned out that it worked pretty well. And based on his prediction, almost a year after the original observation, it was observed again right where Carl Gauss had predicted it. So it was pretty cool. And today, like I say, it was a very complicated set of calculations. There's more than 80 separate calculations that you have to do in order to determine the orbit of an asteroid or a comet. And back then, they did that all by hand. Today, it's all done by computer. Once we have the coordinates of those individual frames, we can plug those coordinates into the computer software, and it will pop out an orbit prediction literally within a fraction of a second. So, one of the great advantages of computers is how fast they can do calculations that used to take hours. I notice you're setting up something there, Richard. What you up to?
Well, I figured I should take. I figured I should try to take a whole sequence of them automatically. but I'm trying to decide whether I just want to keep hitting the button manually or have the computer take a whole series. I haven't decided yet. We got 5 minutes to decide.
Yeah, we are approaching our limit though for hopefully it'll be we'll see the space station before we reach the limit.
Yeah.
As we're at zenith distance, actually we're over it. So in about 2 or 3 minutes here, the software is going to stop the telescope from tracking it. So
yeah. So this may be
it's going to be tricky.
Fool's errand in a couple more minutes.
Yeah. So let's see. You said 10:11 is when
10:11 and 58 seconds. So essentially 10:12.
Oh, okay. Well, keep your fingers crossed here.
Yeah.
Because we're getting really low. And this is live view?
No.
Oh, okay. I see the live view button up there.
Yeah, just the button is just there to tempt you.
Yeah, I've got the telescope slowly adjusting periodically in the direction of the motion, so that helps keep it centered in the frame pretty well. So let's see if I got any other images I can show you while we're waiting here.
Well, it's 10:08. So maybe we should not upset the Zoom gods.
Yeah. Are you just?
I'm just manually doing it because I want to see the photo. When you do the sequence, it doesn't always refresh the screen as quickly as it's taking photographs. But if I do it manually and actually let the screen refresh, there's a better chance we'll actually see it if it does pass through the field of view. So I want to obviously show it to everybody and not search through a stack of photos.
Okay.
Oh, that was good. Yeah. I see what you did. I see what you did there.
Yeah, I'm gonna adjust it a little bit more here. Get it closer to the middle of the frame. There you go.
All right, it's 10:09. Just a few more minutes. Oh, somebody said they got a picture. Cool. One of our viewers here went outside and got a picture. Why are comets so bright? Well, they're bright because they're reflecting light off of the sun.
Yeah. Now
and they become very, very dim as they move farther away from the sun until they're absolutely invisible. Yeah, we're really tempting fate here. It's 10:09. We've just got a couple more minutes. All right, 10:10. And one of our club members told us about this passing of the space station in front of the comet. So hopefully he got that time right. All right, it's 10:11 now. So I'm just going to keep shooting. We'll see if anything shows up. Yeah, that would be helpful. Yeah. Gerald's going to climb on a ladder. Let's see if he can see the ISS.
Yeah, see the space station now? And it should be going by it here in just a second, if it's going to pass. All right, should have passed it by now. Okay, we missed it.
All right, no lottery tickets for me. Well, it was a good try.